Hey everyone, let's take a look at number 3 in section 9.1. It's just two simple problems. I just want you to sort of see the difference between the two differential equations here that are just have one slight change. All right, the first one here is the derivative of y with respect to x is equal to x, and then there is an initial condition, right? Y of 7 is equal to 8. Okay, well, this is really an easy problem in terms of what we've been talking about in this section on separation of variables. We would rewrite this in this form here, right? Multiplying by dx, essentially dy is x dx, and then integrate both sides. Of course, the antiderivative of 1 here with respect to y is y. Antiderivative of x is 1/2 x squared, and don't forget our plus c, which is essentially subtracting the constant of integration from the left-hand side from the right-hand side. But this is nothing more than, this is saying what the derivative of y with respect to x is x. We just integrate, right? Find the antiderivative. So that's all we've done, find the antiderivative. So this is not really anything different than what we've been doing since we talked about antiderivatives at the beginning of the semester. So now we do need to apply the initial condition, right? And so remember what this means. This means when x is equal to 7, the value of y is 8. So I simply replace y with 8, x with 7, and now I can solve for c here. And when I do so, I get that value. And so here is the correct response, right, that you should write. The what you're looking for is the particular solution, excuse me, y, where c was negative 33 halves. If you notice the common denominator here, right, 1/2 x squared is the same as x squared divided by 2. You can write it as one fraction. I think I saw Achieve had this as the official answer for my problem. And again, your problem might have a slightly different initial condition. That's the first one. The second one is very similar. Instead of the derivative of y with respect to x being x, it's now with equal to y. So this definitely is a separation of variable problem. We have the same initial condition here. When I multiply by dx, I get this. I need to get this y over here. Do not subtract, right? I can't subtract. That will not work because it's, think of it as y times dx in a sense. So we want to divide by y. So now I can integrate both sides. What's the antiderivative of 1 over y? Well, hopefully we remember that. Natural log absolute value of y. Antiderivative of 1 is x. And don't forget your plus c here. You have to do this immediately after you integrate. Now we should solve for y explicitly, right? They do want you to write y equal a function of x. So let's do that first, and then we'll apply the initial condition. I'm going to exponentiate both sides, right? Or write this in exponential form. If the natural log of the absolute value of y is x plus c, remember the logarithm is the exponent. The base here is e, and so e to the x plus c is the absolute value of y. Remember what we do here now, e to the x plus c is e to the x times e to the c, right? When we're multiplying like bases to different powers, we add the exponents. And this e raised to some constant is just another constant. Okay, I'm calling it c here. Usually I do like c1, c sub 1 or something like that, but we're sophisticated enough, I hope, to realize that this c here is not the same as this c here, but nonetheless, it is a constant. Notice it's multiplying e to the x, and when I solve for y, right, the absolute value of y is equal to c e to the x. It means y is plus or minus c e to the x. Well, plus or minus any constant, again, is just a constant. So the final solution is y equals some constant times e to the x. And so now I can apply the initial condition to find out what c is. Is c positive? Is c negative? What is it? So remember the initial condition was when x was 7, y was 8. So I replace y with 8, x was 7, and I solve for c. I divide by e to the 7th, so I get 8 over, or 8 divided by e to the 7th, but that's the same thing as 8e to the negative 7 power. So you could write it either way. I just preferred this route. And so now I replace c with that, 8e to the negative 7 times e to the x. So here's the solution. Notice we can combine these two, right? When I multiply like bases to different powers, I add the exponents, right? So this would be e to the negative 7 plus x, which is the same thing as x minus 7. So it could be written this way. If you preferred the 8 over e to the 7 route, it would look like this. or you can write it this way. So I would accept any of these answers. I mean, that's fine. I think Achieve had this one in the middle, but hopefully, again, your initial conditions a little different than mine probably. So I hope this clarifies what's going on here.